Welcome to an example of classifications of functions such as one-one function, onto function, bijections, and invertible functions. Let A is equal to set of real numbers minus set 3 and set B is equal to set of real numbers minus set 1. Consider a function f from set A to set B defined as f of x is equal to x minus 2 upon x minus 3. Is this function a one-one function? Is it an onto function? Justify your answer. Here, the set A and set B are defined like this. The complete real numbers, from there you delete the number 3 to get set A, and from complete real numbers delete number 1 to get set B. And in this function, the domain is set A and codomain is set B. A function is defined from A to B, and the rule is here. We need to check whether it is a one-one function. What is a one-one function? A function f defined from set A to set B is called one-one function or injective function if distinct elements have distinct images. That means if there are two elements which are unequal, distinct, then their images should also be unequal, distinct under this rule. That is, x1 not equal to x2 should imply f of x1 not equal to f of x2. In other words, in case the images happen to be equal, then the pre-images should also be equal. That means whenever f of x1 and f of x2 are equal, it should imply that x1 and x2 are also equal. These are two interpretations of the definition of one-one function. Let's use this interpretation to check this function. Let us take two elements f of x1 and f of x2 are equal for some x1 and x2 of the domain. In case these two are equal, we can say f of x1 equal to f of x2 means x1 minus 2 upon x1 minus 3 equal to x2 minus 2 upon x2 minus 3. That is, to get f of x1, place x1 here. So, we get an equation x1 minus 2 upon x1 minus 3 is equal to x2 minus 2 upon x2 minus 3. Let's simplify further. Cross multiply x1 x2 minus x1 minus 2x2 plus 6 equal to x1 x2 minus 3x2 minus 2x1 plus 6. Now this long expression has many terms same on either side. x1 x2 here, x1 x2 is on the RHS also. 6 and 6. And combine the like terms and rearrange to get x1 equal to x2. That means we took two images equal. It could imply that x1 and x2 are equal. Algebraically we could get simplifying it. Hence we can see this function very well follows the definition of one-one function. So we can conclude that this function is a one-one function. Now we need to check whether it is an onto function. What is onto function? A function f defined from set A to set B is called onto function or surjective function if for each element y that we take in the codomain, there exists at least one x in the domain such that image of that x is equal to y itself. I mean, for each y that we take in the codomain, we should be able to find an x in the domain such that image of this x is equal to the y that we have taken here. Let's check these three stages of this definition. To begin with, let y be an element in the codomain. Let y be an element in the codomain. Now, if possible, let's write this y as x minus 2 upon x minus 3 for some x. If possible. Is it possible? Yet to be checked. How to check? We will find out the value of x in terms of y from this expression. Cross multiply xy minus 3y equal to x minus 2. Taking the x terms common and dividing by the common factor, we'll end up in getting this expression. X is equal to 3y minus 2 upon y minus 1. Now the question is this kind of an x available in the domain? Is it possible to get an x like this? X we have found, but is it possible to have it in the domain? If you look at this expression, one thing we understand. In case you take value of y as 1, the denominator would become 0 and this will go meaningless, undefined, so the x is not possible. But remember, such a situation might arise only if you take y equal to 1. But see, the y was taken from the codomain set B in which 1 is not there. So how would we take y equal to 1? Such a situation wouldn't happen. So for all other y, this calculation will give you a meaningful x, a real number x. So the x that we have calculated would surely belong to the domain. So the second stage is clear. Now, this is not enough. For any y, how to get the x that we have got? But is this y image of that x itself? The x that we find should be in such a way that image of x is equal to y. This also need to be verified. Let us check. We will start with f of x, calculate and try to see whether we will reach y. Only then we can say the function is onto. So I begin with f of x. Let's calculate the image of x. Image of x. What is x? X is this expression. So f of x means f of this expression. Now, how to evaluate this? See, the f rule says f of x is x minus 2 upon x minus 3. So f of this expression is this expression minus 2 upon this expression minus 3. Hence, we will write the next step. X minus 2 upon x minus 3. X is this big expression, this big expression. X minus 2 upon x minus 3 is the f rule. Let's simplify ahead. Taking LCM y minus 1. Numerator we simplify. 3y minus 2 into y minus 1. And the denominator is 3y minus 2 minus 3 into y minus 1. Denominator y minus 1 is common for both numerator as well as denominator, LCM. So we are at this expression. Go ahead. 3y minus 2y is y. Minus 2 plus 2y 0. So the numerator is 2y. Numerator is y. Denominator is 3y minus 3y 0. Minus 2 plus 1 is plus 1. So we get equal to y. So the x that we have calculated, its image we found out and we obtained this y itself as the image. So f of x happened to be equal to y. That is satisfying the third stage also. Hence we can say this definition is fulfilled in this function. This function satisfies this definition. Hence, this given function is an onto function. F is an onto function. So, we have concluded that the given function is 1, 1 as well as onto. A function which is 1, 1 and onto is called a bijection. A function which is 1, 1 and onto is called a bijection. And a bijection always is invertible function and has a unique inverse. So the function given to us is invertible. and it has an inverse. What do we mean by inverse? Inverse is a function defined from b to a so that we are able to find out the original x, the pre-image of x from any image y here. So what would be that inverse? Inverse is that rule with which the previous element x is being calculated using y. Here it is. X is obtained by doing this rule. 3 times y that you take here, minus 2 upon y minus 1. If you do it, you get x here. So in fact, the inverse of this function is this rule itself, the way you would get the x back. This is the inverse. So f inverse y is 3y minus 2 upon y minus 1. For f of x is x minus 2 upon x minus 3.